So hi, Abbas.
Hi, can you hear me?
Yeah, we can hear you.
Okay, should I share my screen?
Yeah, you can start sharing your screen. So I welcome everyone to the session on recommended systems. Unfortunately, the link to this session in the ICSI program was wrong, and the right link is in MidSpace. So you can start your presentation whenever you want, and we will have 5 minutes presentations followed by a final discussion with all the participants. So please write your questions here in the message slot, and we will ask the questions at the end of the session. So please, Abbas, you can start. Thank you.
Okay, perfect. Can you see my screen right now?
Yes.
Okay, perfect. Okay, hello everybody. The title, I'm Abbas Haydar Nouri from Sharif University of Technology. The title of my presentation is Predicting the Objective and Priority of Issues in Software Repositories. This work was done by me and two of my students, Miss Malia Izadi and Miss Kiana Akbari. This work was published in Empirical Software Engineering just past February. So the motivation of the work, as we know, issue tracking systems are now widely used by software development teams, and they provide very valuable information to the team. But in larger scale projects, it's difficult to respond to all issues in a timely manner because there are lots of issues being reported by many users. So we need an approach to automatically identify the objective and priority of issue reports. This is an example of an issue report in a GitHub project. As we see, an issue report contains very valuable information like the author of the issue, the description of the issue, the labels, the participants to that issue, and many other information. And in particular, the labels of an issue identify typically the objective of an issue, whether it's a bug report, it's a feature request, or other things. But in top 1,000 GitHub repositories that we studied, we noticed that about 55% of issues had no labels. And also in our study, we noticed that it is possible to typically classify the issues into a bug report or an enhancement request or a support request. So our goal in our paper was to propose a two-stage approach to automatically predict both the objective of an issue and also its priority. This figure presents an overview of our approach. I don't have time to go into the details, but our approach is in an abstract view is a two-step process. In the first step, we identify the objective of an issue, whether it's a bug report or an enhancement request or a support request. And in the second step, we identify the priority of an issue, whether it's a high priority issue or a low priority issue. And for the data set that we collected to apply our technique, we collected about 70 different information from an issue. For example, the title, the description, the labels, and etc. And for the objective prediction, our data set included around 80,000 GitHub repositories, and we crawled more than 1 million issues from GitHub for those GitHub repositories, and we applied various deep learning techniques, and we noticed that the Roberta had the best results in classifying the issues, and we were able to automatically identify the objective of an issue. For prioritizing issues, we collected 83,000 issue reports from 70 GitHub repositories. Out of them, 45,000 of them were high priority issues, and 1,000 of them were low priority issues. And again, we applied various natural language processing techniques and applied different AI techniques, machine learning techniques, deep learning techniques. And again, we noticed that the random forest, the machine learning technique, which was actually a traditional techniques, had the best results, and we were able to prioritize issues into high priority issue or low priority issue. For the evaluations, we tried to answer 4 different research questions to see whether our approach can predict the objective and priority of an issue. Also, we wanted to see how our approach works in cross-project settings, and also we wanted to see whether our approach can prioritize issues even on unlabeled data. And as we see in these slides, our approach had good precision, recall, F1 score, and accuracy. Also, in a user study that we conducted, we noticed that our approach can work well even on unlabeled issues, which was very good in a user study that we performed. And for the concluding remarks, our approach is capable of predicting the objectives and priorities of issue reports with high accuracy, and it works in cross-project settings as well. And also in a user study, we saw that our approach works well even on unlabeled data. But in 5 minutes, I didn't have time to go into all the details. I invite everyone to see our empirical software engineering paper, as I mentioned, published just last February, and all the details are there. Thank you very much for your attention.
So thank you very much. So as planned, we go for the other presentation from Qiuan Chen. Is it right? So Qiuan, you can start sharing your screen and start your presentation.
Thank you. Bye now.
Thanks a lot, Abbas, and we will see you later for the question time.
Yeah, sure.
We cannot hear you, Qiuan. Were you able to share the screen? Yes. No, the previous screen was good. Yeah. We see it correctly, but we don't hear your voice.
We cannot hear your voice.
Can someone hear the voice? We cannot hear you. Qiuan.
Mm-hmm.
We cannot hear you.
Should I share why? Oh.
Who is speaking?
Wait.
I think one of the speakers is trying to say was he can do
another
the
speaker.
first.
There is another speaker. Yeah.
Yes, who can fill in for this session so that Qiuan can have some time to prepare.
Okay. So Qiuan can stop
Qiuan,
sharing and you can start your presentation. Qiuan, try to. Yes.
Hello?
Hello? Who's speaking?
Hello. Can you see my screen? My sharing screen?
Yes. Yes. And now we can hear also your voice.
We are
So
now
please,
watching. Yeah, we are
Okay.
now watching
Okay.
the slides
Uh,
from
so-
Julian, I think.
I'll start.
No, but I don't understand.
Hello,
who is
everyone. I'm
speaking,
Qiu Yuanchen
guys.
from Zhejiang University, and
Okay.
my presentation topic
Go ahead.
is code reviewer recommendation in Tencent, practice, challenge, and direction. And this work was collaborated with Gongfeng SAI Lab at Tencent. So why does Tencent need such a recommendation system? As we all know, Tencent is a giant company. It has many organizations, and they are divided into small teams.
Sorry.
In general,
sorry.
members
please,
in
sorry,
small
sorry. Please. We don't see the slides changing.
What?
I don't understand who is speaking. Can you write your name here in the message board?
Sorry?
And tell me who is speaking? Who is speaking? What is your name? What is your name? Qiu Yuan Chen is your name?
May I continue? Hello? Hello?
Yeah, okay. Can you write, could you write your name here in the chat so that I can
Hello,
understand?
Jiawei. May I continue?
No, wait a moment before we are able to understand who is moving the slide and who is speaking. Because I see Qiu Chen that is moving their lips.
Okay, can you hear my voice? I don't know.
Who are
Could you hear my
I don't know
voice
who
and
are
see my
you.
screen?
Like, can you see this is your name speaking?
Okay.
Is that Qiu Yuan
I've no idea.
speaking?
Okay, but we
Okay.
don't see, we didn't see the
Can
slide
I start?
moving. Please start, but we don't see, we see, yeah, please start. So. I think there is a delay. So guys, can you stop sharing the screen and we pass to the next presentation, and then we solve this problem and we go back to your presentation, okay? Stop sharing and Qiuan, we have a problem of delays between your presentation and what we see and what we hear. So
Sorry.
we will try again later on, okay? We can try later, okay?
Hello, everyone. Qiu Yuanchen from Zhejiang University, and my presentation recommendation in Tencent, practice, challenge, and direction. This work was collaborated. So what does Tencent need this system? As we all know, Tencent is a giant company, and they are divided into small teams. So in general, you need the automatic code reviewer recommendation, because the developers, they are familiar with each other, and yeah, can you hear me? Can you hear me? Hello, Jiawei.
Jiawei,
Can you hear me?
Can you stop the presentation and we pass to the next presentation, because the delay is impossible, okay?
Okay, let's move on to next
And
presentation.
if you can meanwhile chat with Qiu Yuan Chen so that
Qiu Yuan,
we can handle this later,
yeah,
okay?
Qiu Yuan, please send
Thank
me
you.
message. Yeah, please, Qiu Yuan, please
What's
send
wrong
me
with
message.
the connection?
I'll send a message in private to you.
Hello.
So Antonio, you can share your screen and start presenting. Thank you.
May I continue?
No. Later. Okay, Chen, later, because there is a big delay.
What's wrong? Okay, I continue, and
No.
and
We have to
recently,
mute you.
Tencent is
你的网络延时有点大，你可以暂时先退出。
Okay, Antonio, you can start your presentation. I've been able
Can you see
to
it?
mute. Yeah, we can see it clearly. Thank you.
Okay. Thanks to you. Everybody, and thanks for being here. My name is Antonio Mastropaolo, and I'm a PhD student at the Università della Svizzera Italiana. And today I'm going to present you our work using deep learning to generate complete log statements. And without any start. Okay, so what is logging, and in general, what are logging activities? Well, logging is a widespread activity among developers because it allows them to record the valuable runtime information about applications. And specifically, to each log statement is assigned a specific position in a code snippet. On top of that, each log statement is also assigned with a specific log level that describes the severity of the behavior that the developers want to track. And finally, we also find a meaningful log message for the specific log statement. In order to help developers during these activities, researchers have been presented several approaches during. For example, Log Advisor is one of these approaches presented by Zhu colleagues that can help developers by suggesting them where to add a log statement. And recently, Lie colleagues instead present a neural model, DeepLB, that can fix and suggest already typed log levels. However, these approaches have some limitations because they can only work in a complementary way. In other words, these approaches can only take care of one of these three different logging activities at a time. And in order to overcome these limitations, in this work, we present Lens. Lens is the log statement recommender tool that can help developers by suggesting them where to add a log statement in a JavaScript, by also picking which is the correct log message, and on top of that, also choosing the right log level. Specifically, we built Lens on top of that was presented in 2019 by Rafael colleagues from Google, and the T5 model very interesting characteristics that concern the overall training pipeline. And later, I will give you more details about this specific aspect. But before doing that, let's dive into the approach that we came up with to support the task of complete log statement generation. So at the beginning, we need to construct the dataset needed for building, actually for training our approach. And to do so, what we did was to collect more than 5,000 Java repositories hosted on GitHub. Then from these repositories, we extracted only these repositories having an explicit dependency towards Log4j. After that, from these repositories, we also extracted more than 6.7 million Java methods having no log statement. And finally, we also extracted more than 153K Java methods having at least one log statement. And later, we were ready for experimenting and for evaluating our approach. As I said before, the T5 model has these very interesting characteristics concerning the overall training pipeline, because specifically, the training pipeline is given by two different phases, the pre-training and the fine-tuning. During the pre-training, the idea is that we want to let the model learn how to deal with the specific token of the language that the model itself is working with. In other words, if we are working with the Java language, at the end of this pre-training phase, what we wish is that the model has learned how to deal with the most recurrent pattern of the Java programming language. And in order to do so, what we did in our study was to run, during this specific process, was to randomly mask 15% of code tokens in a Java method, and then we asked the T5 model to predict these masked code tokens. Instead, during the fine-tuning, we want to specialize the model on the EMX support, in our case, complete task. And to do so, given a Java method as input, we stripped away one log statement at a time from this Java method, and then we asked the T5 model to inject back the complete log statement into the method. At the end of this very process, what we have is a fully trained model that can support developers by suggesting them where to add a log statement into Java method specifically, as I said before, it also picked the correct position and the correct lock level. The results that we achieved with this approach are the specific lens to be correct in 66% of cases concerning the log level. Instead, the lens correctly predicted the position in a Java method of the log statement in 65% of cases. In 16% of cases, lens correctly generated the log message as a real developer would do. And finally, in 15% of cases, our approach correctly predicted the log statement, in this case, the log message, log level, and on top of that, also the log position. And with the results, I would like to conclude my talk. Thank you very much.
Thank you very much, Antonio, also for being in time and on time. And now we have the next presenter that wasn't here at the beginning of the session, but who's presenting now for the modeling review history for reviewer recommendation.
Hello, Chair. I'm here to, I'm ready to present.
Great. You can share your screen and start your presentation. Thank you.
Okay. Okay, so everybody can see our PowerPoint?
Yes.
Okay. Okay, hello everyone. Good morning, afternoon, evening, or night. Okay, depends on where you are. And my name is Huang Hongyu, and I'm representing the whole team. And it is our great honor to present our paper, Modeling Review History for Reviewer Recommendation, a hypergraph approach in the ICSE conference. So let's get started. So code reviews, as we all know, is now playing a key role in software maintenance and evolution for both the big IT corporations such as Google and also the open source software community. So during the process, recommending suitable reviewers can greatly improve the efficiency of code review. When we talk about code review, that means specifically for, especially in the open source software community, we are talking about reviewing the pull requests. But the reviewer recommendation is especially challenging in context of open source software projects due to their loose organizations, especially when compared with the big IT corporations. So researchers then proposed a set of automated recommenders based on modeling the review history. So we could see a recommendation paradigm in general, that is to build a recommendation model from the historical reviews. So when a new pull request comes, the models could recommend usually a candidate list of suitable reviewers on the list, so that the organizers or the manager can choose from the candidate list for the suitable reviewers instead of searching the entire project members. So in recent research, the graph-based modeling is considered as a promising way for reviewer recommendation because so in particular, they will model the review history in graphs. And by doing so, their recommenders can draw strengths from both proposed heuristics and learning algorithms. And more importantly, they argue that the modeling through the graphs is a more natural way to reflect the reviewers' collaborations. So in particular, in this paper, we argue that modeling through the ordinary graphs is difficult to depict the in-depth collaborations. We were talking about the PR reviews with 3 or more reviewers in the review history. And we argue that this is a quite common phenomena in daily practice because as as our investigation shows in the TensorFlow project, there are 71% of the PRs are reviewed by more than 3 reviewers. And there are 2 PRs that are reviewed by up to 22 reviewers, so that the review the code is not just an important practice, but also also the one with intensive collaborations. So if we want to model such existing PRs, so we could see in the ordinary graph, a full reviewer review will be modeled as a complete subgraph with 6 edges, so that for each edge, it will only capture part of the collaboration. So if we want to further build a recommender, we have to consider the overall 6 edges, so that it's hard for the recommender to perform. So in contrast, we propose that modeling the review history with hypergraphs is a much easier and more natural way to model the review history, because in the hypergraph, a hyperedge means that all possible connections between just use one hyperedge to represent all possible connections with all potential vertices. So that's one of our goal. Another goal of our work is that we want to at least show our concern on the review workload issues, because review histories show that only a few core reviewers do the most reviews. So since all the recommenders are built upon this the historical reviews, so they will, if they are built and put into practice, these recommenders will further increase the core reviews workload for sure. So that when doing our work, we also expected to recommend a diversified candidate reviewers by using the hypergraph to model the review history, and also we introduced the recommendation diversity metric in our evaluation. So so in general, our work starts from the construction of hypergraph. So when we model our PRs from the
could you move towards the conclusion? You have exceeded the 5 minutes, so if you could hurry up a bit.
Okay. So this is how we construct the hypergraph, and this is the way how we make recommendations from the hypergraph. And that's our experiment results shows that our approach can performance well in both the accuracy and the recommendation diversity. And that's all for our presentation.
Thank you very much. Sorry, but we have this tight schedule and we have to allocate 5 minutes for each one. So, yeah. And please stay with us for the presentation, for the discussions later on. So now we have Chao Liu, Shell Fusion, answer generation for shell programming tasks via Knowledge Fusion.
Yeah.
Please, you can share your screen.
Okay.
Okay, it works. Thanks.
Okay, I'm Chao Liu from Chongqing University. I present our work, Shell Fusion, answer generation for shell programming tasks via Knowledge Fusion. And well, shell programming is widely used in various platforms such as Linux systems. Just as there are over 50,000 shell commands documented in official many pages of Ubuntu. And the challenge is, given a shell programming task, how to quickly find the appropriate shell commands and the corresponding scripts. That's our challenge. And we can find the source from the answer from 3 sources. The first one is the official menu pages such as from Ubuntu. But the documentation is too lengthy and hard to read and understand, a lack of practical examples. And the second is the TLDR. It gives some easy-to-use tutorials. We can find some from the GitHub. But the TLDR only covered a limited number of shell commands and show the most simple ones for the beginners. And it lack of explanation for the command and the options. And the third choice is the question and answer data, such as ask Ubuntu and Stack Overflow. the QA data provides some useful commands, but it also lacks some explanation from the commands and then options. And from these three resources, our motivation is to how to fuse this useful knowledge from multiple resources to solve the shell programming task. We present our work, Shell Fusion. It have two parts: offline processing and answer generation. The offline processing processed the three sources of data. First, we obtained the shell-related questions from 4 QA communities. Then we obtained shell commands from official menu pages. Next, we obtained the shell commands from TLDR tutorials. Now, with these three resources, we have some examples, menu pages, and descriptions. When we processing the second part, online answer generation, we first retrieve the top and similar questions for each query. Then we detect the shell command with options for each description. And we filter irrelevant comments out and return the top key related comments. And we re-ranked the candidate commands according to the similarity to the query and similar questions. And finally, we generate the answer with 4 parts: page summary, TLDR, data, and question and answer, question and the scripts, and the explanation from official menu. We tested with some practical queries from question and answer questions. We first tested the parameter k of the Shell Fusion according to 50 randomly selected queries, and we proved our effectiveness compared with one state-of-the-art Magnum and 3 variants of Shell Fusion. It shows the improvements of the Magnum. Also, Shell Fusion works fast with only 0.4 seconds per query. And finally, we conduct some user study to prove the usefulness with 10 queries and 20 participants. And from the results, from the feedback of the user participants, we can see the generated answer is comprehensive and easy to read. And Shell Fusion can help programmers to address tasks more efficiently and accurately in practice from our experience. And that's our work. Thank you very much.
Thank you very much. Thank you. Now it's time for Moshi. Is it right? Clear, contrastive learning for API recommendation. Thank you. Please share your screen and start your presentation.
Okay. Can everyone see my screen?
Yes. And now it's in presentation mode.
So progressing? Everything works?
Yes. Yeah, everything is fine.
Okay, good. Let's start. Okay. Welcome to the presentation.
Today I'm presenting the paper. My name is Moshi. API recommendation have been studied for years. It takes a programming question as input
and returns API as answer. Currently, there are 1.8 million Java core flow and 4,500 APIs available in Java ecosystem. There are more APIs adding to it every year, so finding the right API is time-consuming. Biker is the leading tool for this task. It trains a work-to-back embedding with Java Post. Then user provide a query to the model. Then it compares then it recommends APIs by comparing the similarity of other posts and also API documents. However, Biker is weak in modeling semantics. So here in the example on the left, The answer from Biker missed the key API buffer reader. Biker thinks these two APIs are similar because they have same context. This is because word-to-vec model gives us static vector for token with same context. And in the example on the right, Biker picked a post that has opposite meaning to the query. The bag of words representation is weak at capturing sequential information. So from these, we know we need better embeddings to alleviate the problems. So we propose contrastive learning for API recommendation. The advantage of contrastive learning is the model focuses on the answer or not, rather than learning the details of the instance. So the learning goal is simpler and the generalizability is better. This is an overview of CLEAR. So first, we collect QA pairs and store them in a database. Next, we collect post triplets for each post. Then we train the model with contrastive training on a Roberta model. The Roberta model generates 3 embeddings for the posts. Then the loss function updates the model towards the direction that minimizes the distance between positive sample and anchor, and also maximize the distance between sample and the anchor. So next, the trained model is used for filtering similar examples from QA database. So for each instance, we select the top 50 most similar pairs. Then the query and candidates are concatenated as one input given to another Roberta model. Now we use cross-entropy loss for classification. So these are nothing fancy here, right? So search phase, a user provides a query, then the filtering model picks top 50 candidates again, then re-rank at least relevance score. In the experiment, I comparison as baseline as well. These So also we add to the difference and the effectiveness contrastive learning approach.
Disappeared. So Moshi is not here anymore. Apparently, I will try to contact him for a moment and then we can so meanwhile oh shit.
I think we can proceed. I can contact
Yeah.
Moshi. Yeah.
You can contact Moshi, but yeah, I think that the
Yes.
overall presentation can be considered closed. So Q1 Chen, do you want to try again? If it doesn't work, and if you can be like a bit quicker than the 5 minutes, so we have enough space to talk. No, we don't hear you. So it's no, it's still try to switch off the camera. We don't hear you. There could be some. No, it is the same as before. So we don't hear you.
Can you hear my sharing? Can you hear me?
Sometimes,
Can you hear me?
Sometimes yes, but it's delayed. So it's better that we pass to the question and answering, because otherwise
And can you see
we
my
continue
sharing?
with the technical. We
Hello.
hear you with delay. Is everyone
Can
hearing
you hear
delay?
me? Can you hear me?
With strong delay, okay? So it's very difficult to follow you if we hear you with this delay. So, okay.
Hello.
So, hi Moshi. Yeah, we've lost the end of your presentation.
Sorry. Shall I make up the last part? Where did I drop
Yeah,
off?
just do the closing conclusion of your presentation and then the closing remarks, and then we pass to the discussion.
Okay. Sorry, it will be here. This graph. Or
Yeah.
later. Okay. So this
Whenever
graph
you
shows.
think it's appropriate.
Okay. So this graph shows the before and after training. So before contrastive training, the clusters are mixed and there are inputs that cannot be assigned. After contrastive training, the boundary of more clear. So in summary, API queries, and also the experiment confirms the effectiveness of CLEAR for both cloud.
Thanks everyone, that's my presentation. Is it good now?
Okay, thank you very much. So if you have any questions? If you want to ask a question, you can either write it down here in the chat or just open your microphone and ask your question. You can ask questions to individual presenters or general questions. So if there are, okay, at the moment there are no questions, so I will start asking questions. I have a question for Antonio, and I was wondering that by reading your paper, what I saw was that natural language generation was quite poor, with like 50 to 15% accuracy. So I was wondering how much disturbing is it while using the tool, and how could this be addressed? Maybe different language models, different learning models, or what do you plan to do? Because I think this, of course, is a shortcoming,
Yes.
but also a good avenue for further
Yes.
research.
Yes, for sure. For sure. Indeed, as we highlighted in the paper, it seems that the log message itself is acting as an upper bound, even for the most challenging scenario. So it's very likely that if we can improve in some way this specific aspect, the log message as well, also all the other things will be improved. And specifically, to answer your question, we may think about several approaches in order to further improve the log message. For example, we can think about information retrieval approaches, and then we can combine together information retrieval approaches and generation approaches like the one that we are using so far. So in other words, what we could try to do to address this specific aspect is, let's say, that we take log message generated by Balance, by the TFF model, only when the confidence of this message is very, very high. And when the confidence of the generated message instead is low, we can rely on an information retrieval approach. This is something that we can do, and we could experiment further with it.
Yeah, it looks like a sensitive idea. I mean, because you need also to rely on the technology that is out there for natural language generation, and it's not like it's still something that needs to be developed sufficiently. Yeah.
I also have a question. I'm sorry. I also have a
Sure.
question for this. Yeah, if you don't mind, how did you handle the domain problems with the software engineering development? Because I know that language generation problems like sequence-to-sequence learning is very sensitive to different domains of the training set. Like, how do you manage to craft a particular domain? I mean, the technical details here. How do you craft such a domain-specific data set for our software engineering task?
Okay, in this case, we run our script in the wild, meaning that we try to collect many instances as possible, coming from as many projects as possible. So in this way, we kind of let the model to learn how to deal with all these variants that is within the data.
Okay, thank you.
Welcome.
We have another question for you, Antonio, from Teksu, Kim Teksu. Kim, if you want to ask the question yourself. Kim?
I
Kim.
can read the question.
Yeah. So the question is,
Okay.
thanks for the impressive presentation. Yeah, microphone is not working. So can you briefly explain how did you make a judgment whether a generated log message is meaningful or not?
Okay, very interesting question. Okay, here the two authors basically we have the log message generated by Lens, and then we have the target one, right? Individually, we marked if this log message, the wordings composing this log message in a way were similar and capturing the same semantic of the words that compose the target log message. If so, we marked this as a meaningful. Otherwise, we mark it as not meaningful. Then, this process individually, a third author solved conflicts eventually. I hope this answers your question, Kim.
Thanks. Yeah, Kim is saying thanks a lot. Interesting. Okay, thank you, Antonio. Other questions?
I have a question for Mushi. Hi, Mushi. I do see a lot of very interesting tools, which is machine learning based for software engineering. I was just wondering if you have follow-up work so that you make your tool like a web server or extensions for some IDE environment, because I do see some such applications. So just wondering if you have such plans.
Yes, that's a good question. Yeah, I believe if we extend this work to a plugin or something to Visual Studio Code or IntelliJ,
Yes.
it will bring more value. Yeah. I could imagine it will be like something close to Copilot, where you give description of the method in code comments. Then it will search, it will grab these comments, then search through our database with a dedicated server, then return the most relevant API, and also use these API as index, redirect to most similar like code snippet, and use the API as index of code snippet. I think it will be the most likely scenario of the plugin. Yeah.
Yeah. Can you also let me, if possible, like do you have the data about the execution efficiency? Because as if that's a real-time API recommendation, it will be that will be a factor.
Yes. Yeah, that's a very good question. I cannot say our experiment is fast because it's not as fast as a real-time thing, but every query will be finished executed within like 0.1 second. It's not millisecond level. There's still plenty of room for optimization, but it's not very slow either. So yeah, in terms of efficiency.
Yeah, thank you. I believe so, because when we propose an approach, we will give the priority to performance, and then we see if we can improve the execution efficiency. So I'm just curious about, like, when I did my research, I found the API recommendations actually very necessary for development, and in particular for Python development. But I noticed that there were no so much work or no so much add-ons from the existing IDE environment. So I'm just curious if you can. It will be great if you can provide such tools available to us. Yeah. So just my personal question. Yeah.
Yeah, that's a very good question. Just one more sentence on that. So when I did my research, I found Facebook has a program called FAISS, FAISS, that produce static vector or embeddings for a model. So essentially, we can fully train a model and provide a list of data, like a knowledge base or something, and extract all the embeddings as static vector and make it a lookup table.
Locally.
So we can later use same hash or other thing to speed up the similarity similarity computation with these static lookup table.
Oh, okay. Yeah, I think that would be very realistic to see them appear in our development tools. Yeah, thank you very much.
Thank you.
Thank you. Other questions? So I have a question for Hongui about the paper modeling review history. And I was wondering, I don't know about code reviews, so my question could be silly, but I imagine that people may have different approaches for reviewing, like a novice could check line by line and checking fine-grained mistakes, and someone that is more expert may check for typical mistakes. And of course, like experts do certain mistakes and novices do other mistakes. How is this considered in your approach? Is it something relevant or?
Okay, that is an interesting question for code review as the whole. But for our approach, for just this paper, our goal is to find at least one proper reviewer for upcoming pull request. And as the content, we have some corporations with the big corporations, and that's actually part of my ongoing work to see if people are happy or not in their code reviews. I'm analyzing their sentiments on it, and with that analyzed sentiments, we could see that if like the reviewers are happy, are satisfied or not for the work that the one has just submitted. And we see actually a strong correlation between the two. If he's satisfied, the reviewers is satisfied, they're doing well, and if they are not, they are maybe not be that happy. But that's
okay. So it's the point of view. Yeah. So the appropriateness of it's evaluated by the reviewer themselves. It's not based on the style of reviewing, like the evaluation of the choice. Okay. And so because I saw in the paper you also have some form of tool support. So this can be because you did a test with human subjects. You did an experiment with human subjects. So I was wondering how much tool support, like how close is your approach to be incorporated in the process of also of a company, for example.
Okay, but we are still talking about the my ongoing work, right? Not just the paper, right?
Yeah, your ongoing work on this.
Okay.
Yeah.
I think that's actually quite interesting because inside the company, everybody is working hard, so they can be more straightforward in writing their review comments, such as I think this is okay or this is not okay, or you are making mistakes, or you are bringing something like the technical depths. So they are very straightforward, so that because they are written in Chinese, and I think the Chinese NLP tools are working fine with our analysis results. And I think that is maybe not that case when it is going outside the company, or especially for something like the Stack Overflow, because everybody is discussing stuffs and giving questions, so that they will be more polite in general, so that they analyze sentiments from the reviews or the ideas, maybe not that straightforward. And also a lot of, as we are programmers, a lot of people are just being sarcasm.
Okay, even in the reviews. Yeah.
Yes.
Okay, thank you. So other questions for our speakers?
I also have about the modeling review history for review recommendation.
Hello, Antonio? Yeah.
Okay, so basically I was wondering if the workload problem is somehow related to newcomers code reviewers, because I mean, what I feel is that in the beginnings, newcomers take care of fewer code reviews due to limited, knowledge of the system. And I said, was wondering if your approach can take into consideration this aspect.
You mean how to involve the newcomers into the reviews, right? Okay, something like the cold start problem, right?
Yes, kind of, yeah.
I don't really think there is some silver bullets for any cold start problem. I think maybe I'm wrong. And I think if just for our approach, maybe maybe the manager of the project can manually set up some successful reviews, and we may just tune up the weights of the newcomers, so that we are trying to encourage more reviews. Yeah, for more diverse. Yes.
Hello, Kong, can you hear me?
Yeah.
Yes.
Okay. Oh, sorry. And I have a question for the modeling to the reviewers. I wonder how quick can the model be established? Because our system in Tencent, the code reviewer recommendation system, they need a very quick response, because the reviewer, when they are seeking the reviewers and the page, they should they don't need they don't want the page to be very slow, because it is embedded into the workflow of the writing code. So how quickly can the model be respond to the results?
Okay, let me confirm with my students. 就是使用模型的话是多长时间 ？Okay. So my students just talk something about the details that even for the large system with some some approaches for the performance, if we introduce some additional techniques for the better performance, even for the very large system, it's by just using the model, we could return a recommendation in about 5 minutes.
5 minutes. Oh, yeah. Okay. So can there be some space to optimization to be able?
Okay. I don't because that's not one of our that's not our concerns. But from my feelings, there's maybe some work that could make the trained model more lightweight. I think there must be some approaches, because I know something about the TensorFlow and the TensorFlow Lite. I think it's something for the trained model, just for the mobile phones or something else, something like that. So we could turn the models to be more lightweight, so that they could maybe run faster.
Oh, okay. Thank you.
Thank you.
We have probably time for another question for the remaining presenters. I have a question. Oh, someone? No. I have a question for you, Abbas. Abbas, are you there?
Yes,
Abbas? No.
Hello?
Yes,
Can you hear me?
Yeah, I can
Okay.
hear you. So my question is a general question about your work. It's very interesting. Of course, it has very few weak points because it's been published already in a journal. So I was wondering, since you are dealing with issue classification, basically, I was wondering to what extent your approach could be ported also to classification of requirements, because some issues are also requirements. In requirements engineering, we have a problem that we are dealing with requirements document written in the form of SHAR requirements, okay? And in the community, we are always working with the same data set, basically, that has been developed several years ago and is not and is not representative. I mean, of it's good for doing research and iterations, but is not sufficiently large as the data set that they are using with issues. So I'm wondering whether you can elaborate on what can we learn and what can we reuse from your research.
Okay, actually, as I mentioned, when we wanted to identify the objective of an issue, we classified it into a bug report, enhanced